Hello everybody. Today, me, Nseri Ilyas, and my friend Ardwan Hamza, we will present our Python project for the presence marking, especially in the schools. So, at the beginning, we will talk about the context, which represents the causes which push us to digitalize the absence marking system, which are first of all, not having to manually mark the presence during the session, and to facilitate the absence control for the administration. Because as we know, using just copybooks and papers or in general manually tasks take a lot of time. On the other hand, detecting faces automatically allows to avoid the errors and accelerate the tasks. So the presentation is divided into three or five principal parts: the approach, the tools used, the demonstration, and finally the prospects and difficulties. Regarding the approach we followed, it's based on the three-tier architecture. The first tier at the administration place to control and display the presence of students. The second tier is the classroom linked to a camera to identify the students present from one or more classes in different subjects. The third tier is where we find the database which store the data relating to the system. So to do this, we use Python and its tools as well as mysql.
Our project we worked with a lot of tools. First of all, we used in our front end a basic bootstrap template. It was easy to set up, as well as it was supporting a lot of JavaScript plugins. The next tool is our MySQL database. It provides a lot of connectors and drivers, and for our project we worked with MySQL connector for Python. After that, to link our database with our front end, we used Flask. Flask is a micro framework used to create web application. It is very light. It has a little number of libraries, which makes it very fast and flexible. Finally, we used the most Finally, the most important tools we used are opencv and face recognition. Let's begin explain opencv. Opencv is a use open source library for computer vision, machine learning, and image processing, and now it plays a major role in real-time operation, which is very important in today's system. By using it, one can process images and videos to identify objects, faces, or even handwriting. When integrated with other libraries such as face recognition, Python is capable of processing the OpenCV array structure to analyze it. Let's take an example. Looking at this image here, we can see that it has a lot of information. From the above original image, a lot of information that are present can be obtained, like there are two faces and one person in the image wearing a bracelet, a watch, etc. So by the help of OpenCV, we can get all of these types of information from the original image. That was a basic definition for OpenCV. We can now continue to the face recognition tool. The face recognition library, it's used to recognize and manipulate faces from Python or from a command line. It's very simple and easy to use. It has an accuracy of 99.38%. So the question is, how does deep learning plus face recognition work? So it's very simple. All we have to do is follow these four steps. First, we look at the picture and find the faces in it. Second, we focus on each face and be able to understand that even its face is turned in another direction or in a bad lightning, it's still the same person. Third, we be able to pick up unique features of that face that you can use to tell it apart from other people, like how big the eyes are, how long the face is, etc. Finally, we compare these unique features with all the other images from our dataset to determine the person's name. Step 1 is finding all the faces. To find faces in an image, we will start by making our image black and white because we don't need color data to find faces. Then we will look at every single pixel in our image one at a time. For every single pixel, we want to look at the pixel that directly surrounding it. Our goal is to figure out how dark the current pixel compared to the pixels directly surrounding it. Then we want to draw an arrow showing in which direction the image is getting darker. We repeat that process for every single pixel in the image. You end up with every pixel being replaced by an arrow. The end result is we turn the original image into a very special representation called HOG, or histogram of oriented gradients. To find the faces in this HOG image, all we have to do is find the part of our image that looks the most similar to a known HOG pattern that was extracted from a bunch of other training faces. Using this technique, we can now easily find faces in any image. Here is an example. And here is the end result. We can detect the faces using this technique. Second step is posing a projection faces. Now we isolated the faces in our image, but now we have to deal with the problem that faces is turned in a different direction. Uh, to do this, we are going to use an algorithm called face landmark estimation. The basic idea is we will come up with 68 specific points called landmarks that exist on every face: the top of the chin, the outside edge of each eye, the inner edge of each eyebrow, etc. Then we will train a machine learning algorithm to be able to find these 68 specific points on any face. And after this training, here is the end result. In step 3, we encode faces. Now we are in the interesting part. We need a way to extract a few basic measurements for each face. Then we could measure our unknown face the same way and find the known face with the closest measurements. For example, we might measure the size of each ear, the spacing between the eyes, the length of the nose, etc. The secret is a technique called deep metric learning. I assume that you have a prior experience with deep learning, and as we know that we typically train the network to accept a single input image and output a classification label for that image. However, deep metric learning is different. In this example, the input is three images. Two of them are the same picture. In one is one for random person. In each person for each image we generate 128 measurement by the neural net. And we compare all the results and tweak the results to slightly make the pictures of the same person much closer to each other, and the picture of the random person much further. And here is example of the measurements. This network itself was trained on a dataset of 3 million images on the labeled faces in the wild dataset. And as mentioned earlier, it has an accuracy of 99.38%. The step 4 is finding the person names from the encoding. This is the last step, is actually the easiest step in the whole process. All we have to do is find the person in our database of known people who has the closest measurements to our test image.
On and now we'll move on to the demonstration for seeing the different parts of the project. So first we will show you the design of the database we used for data storage and retrieval. And of course here we have the most important table until now. There is student, class, and science or session in English, subject, and present student, where we store the students who presented in the session that surround them with current dates. Moreover, for the test of the application, we only used 6 students, and as you can see here, there is just 6 students, and each image has its own code, which at the same time represents the student ID in the database. So, secondly, we have the main application that we have to link it with a camera in a classroom in order to detect the faces of the students who have attended the session that have taken place in this classroom. So, after the execution of the code, the camera of the PC starts to detect the faces as well as the program send requests to the database to store the presence of those students. So finally, we developed a website based on the Flask library in the backend and HTML and Bootstrap in the front end, as well as Ajax for the automatic refresh of the page. So after starting the program, here in this website we can access the dashboard to see the list of students by specifying the date and the session from those combo box. I just created a session on Friday from 1 p.m. to 6 p.m. For our class Easy 1. The subject is Java and Python, and now let's select the current date here in the website and the subject. So here we have the list of students, and of course all of students are absent in this session. As you can see, the ID 555 is not yet marked present in this session. This ID is represented by my face. So after the program detects my face, we will automatically see that the value A is changed by P. And now we will do a test on the program linked to the camera. And here we type the following command: Python main video pompy. That's our main program. Now we will wait a moment until the program starts to detect faces. You can see here A for absence. We will wait for the program to start detecting faces. Now start to detect, and you can say here P, that's mean present, and that's the purpose from our app, and that's it for the demonstration.
And now let's talk about the difficulties we faced in our project. Some of them, this is new for us, like using Python and also machine learning. So we had some problems with working with Python and understanding the library of face recognition, also how understanding how Flask works. Now let's talk about the prospects of our project. Uh, in the prospects of our project, we intend to improve our backend, add a lot other functionalities, also to the distance management and time management. We improve our database and also improve our front end and add other interfaces. Thanks for your attention.